This video is about sharing some of my knowledge about unit testing using xUnit, Fluent assertions, and NSubstitute. What is a unit test? A test written by a programmer for the purpose of ensuring that the production code does what the programmer expects it to do. There are other types of tests. Acceptance testing, written by business around acceptance criteria. Business analyst or a quality assurance person authors these tests. Integration tests, written by architect or lead to ensure all the system components are written correctly. System tests, written by architect or lead to ensure subsystems are written correctly. Let's look at an ideal test automation pyramid. We can break up tests into different categories, with unit tests having maximum number of tests and manual tests having the minimum. Unit tests can be run after the build process is complete and unit test failures treated as a build break. So if you look at this pyramid, we have unit tests as the base, and there will be a lot of unit tests. There should be a little less system tests, a little less GUI tests, and these are automated GUI tests. And finally, only the things that cannot be automated should be run as manual tests. Manual tests it's hard, there's humans involved, it's prone to mistakes, and it takes a lot more time. So if we can get as much as tests done at the unit test layer and have it running as part of the build process, when the build comes out, we have a level of confidence. And then after the build is done, we can have some release process where release process runs some integration tests and system tests and so on. It could be at different stages of the release. Goals of unit testing. Ensure your code does what it is supposed to do. Reduce brittleness of code. Produce well-written productive code. Enable test-driven development. Enable rapid development feedback. We don't have to wait for an application start or installation of a service. Ideally, you can tell a new member in the team that they can change anything in the production code, and tests will catch all business requirements. This gives them confidence to go change code, try out stuff, and implement features that they were asked to do without the fear of breaking existing code. It is also preferred that one test fails for a reason so that it's easy to pinpoint the business requirement. Unit tests should be fast, repeatable, order independent. Test public methods only. Able to run in parallel. Avoid making private methods public for the sake of testing. Building for unit testing. Building software as small testable units by adhering to solid design principles. There's a lot of articles about solid, so I wouldn't go into all that. But the gist of it is small classes, single responsibility. That makes it easier to test. You know what the class is supposed to do, and the test knows what it is testing. What is legacy code? So one definition of it is legacy code is code written without tests. That implies you could be writing new code, you have no unit tests. The moment you check it in, it is legacy code. If someone else were to pick up your piece of code, they would be scared to change it because they don't know what it's supposed to do. They don't know if they broke it, did not break it. You might have had this experience when you join new teams, and if the team is poor in its unit test coverages, you can't confidently make changes because you just don't know what side effects it has. Here are a few building tips. Use dependency injection. Anytime you new up a class, you have taken a strong dependency. Static classes are harder to mock. Prefer declaring it as a singleton in your dependency injection. Functions should hardly be more than 20 lines long. If it's much longer, it may probably doing more things, making it harder to test, making it harder to even understand. Even for you, you come back 6 months, you'll see a bunch of lines together. Oh, what does that do? Would it be nice if it was just a single line that just said what a block of code did? And also that means try avoiding comments in code. You just want to just put declarative blocks, and each declarative block is actually a function. Use modern frameworks like .NET Core. It has better support for DI, and so it is easier to test. Unit test naming guidelines. Often you'll go into teams that may have rigid policies around how a name should be. And in generally, that is a bad idea. There shouldn't be any rigid naming policy. You simply cannot fit a high-level description of a complex behavior into a narrow box of such a policy. Have the freedom to express. Name the test as if you were describing the scenario to a non-programmer who is familiar with the problem domain. A domain expert or a business analyst are good examples. Separate words by underscores. It helps improve readability, especially for long names. Do not include the name of the method under test in the test name. You don't test code, you test application behavior. Therefore, it doesn't matter what the name of the method under test is. Also, you could be changing the production code. The unit test should just be verifying that the business requirements are still met. So what is the basic testing pattern? Usually we say it as AAA, arrange, act, and assert. Arrange, create all the preconditions of your test, setup, creating classes, whatever is required. Then you have the act stage where you just run the test, and then you go to the assert stage where you check what are the results and if they are good. Tools of trades. So the past few years, I've been using these three frameworks. One is xUnit, since xUnit is cross-platform and .NET Core is cross-platform. I like Fluent assertions. It expresses well and you can chain different conditions onto it. And I like NSubstitute for substituting interfaces. In the past, I've used mockq, but I prefer NSubstitute these days. Next, we'll look at a few samples of different features. I mean, all these documentations are available on their website, so I'm just going to pull out a few key things that sometimes people miss, or sometimes people are like, oh, it can do that. So those are the things I'm planning to show in the rest of this video. All right, first up, let's look at some of the xUnit features. Okay, if you have asynchronous functions, use async task. xUnit runner knows how to wait for these tasks, so don't go by the normal MS test. MS test could have changed, but normally in the past, everything would be just public void. And you do not want to use async void either. Write async task. If you have any asynchronous methods following this is an example I have on the screen here. And xUnit will await for your test to complete. xUnit has two types of tests. One is fact, the other one is theory. Fact is normally like other unit test frameworks where it just executes a specific test. Theory is where we can use the same test but pass it different variables. Showing this with an example. Here there's a persons class, and to create a persons class, the first name and last name is required. It cannot be empty. If it is, it will throw. So this is the declaration of the class. And in the next slide, you will see how I'm going to use xUnit theory to test that these conditions are being checked. Okay, here we are using the theory, and I'm using inline data to pass two different values to the exact same test. So when you have this theory with, say, those two inline data, xUnit breaks it up as two different tests, where the first test takes in the first name as the parameter, and the second test takes in the last name as the parameter. And even the xUnit, the test runner, will show this. You can see on the below I have required parameters are provided, and within parentheses we have first name, and for the second name we have last name. So if there's a bug where I only miss it for the first name, then only the first name test will fail. And the test names are business requirements, that first name cannot be empty, and that's exactly what that failing test is going to tell us. You will also note that in the test runner, the underscores have been replaced by spaces, and that is an interesting feature a friend of mine added to xUnit, and I'll show that in the next screen. So in xUnit now, you can express characters that weren't previously allowed in a test name. Like to get a space, you can use underscore, and you can use XML escape characters to display characters like not equal to, greater than, less than symbols. All you need to do is add this xUnit runner JSON file and set that file to be copied to your output directory. I have placed the contents of the file. If you put this content the way I just have it on the screen, you will get this behavior where the tests are nicely readable without any of the underscores. Here is another interesting fact about xUnit. The constructor and dispose is called for every test. Usually in a class when you have multiple methods, you would expect your constructor to be executed once and dispose to be executed once. This is not the case with xUnit, and people usually do miss it and comes it as a surprise. Just understand that I have two test cases in this particular sample. The constructor would be called 2 times, and the dispose will also be called 2 times. So each run gets its own construction and destruction, which means you can clean up after a test before the next run runs. And xUnit runs a lot of these in parallel, which is another reason why they do it in this fashion. You have to be careful not to step on each other when you're writing your tests. In xUnit, you can also have your own attributes. So instead of using fact, you can write your own attribute, derive it from the fact attribute. This lets you check for some preconditions, so to decide whether you want to actually run the test or skip it. In this example, I only want my unit test to run if the SQL storage emulator is present, and I check for it by checking for the existence of that particular exe. Then the test just runs the exe, and then I have the emulator and I can run the test. If that file was not present, xUnit will skip it, and it'll give the reason that you gave it in the skip. In this case, it's going to be ignore, since there is no blob storage emulator. So this is a nice feature to have at runtime to check your environment and skip tests. So that if a developer doesn't have the emulator, it'll skip on their machine. If the build server doesn't have it, it'll skip it on the build server, so forth. And you can think of various things like that too. If you have different kinds of hardware requirements, is your hardware attached? Do you have the mic? So on. Use fixtures for expensive one-time setup. .NET Core, when you write web services using Kestrel, the .NET Core gives you MVC testing library that has this web application factory they have written for you, where you just provide your startup class. They will take care of hosting the web service in process memory so that you can actually make HTTP calls to the APIs and confirm that your routing is working correctly. In this example, I have the person's controller, and when we call the root of that controller, which is API/persons, it's just returning a text saying person's controller. In the future, it could actually hit some database and return the number of people or the actual people on the back end. So this is a use case for fixtures. They have expensive setup. If you did not want things to run in parallel, you could derive your own class and then put it into a collection and then put the collection name on top of this class so that every test is run in sequence. That way you won't have tests interfering with each other. In xUnit, tests run in parallel. So if you wish to see the output, you shouldn't be just writing to console.out. Instead, if you add itest output helper to your constructor, xUnit will inject a class for you, and it has the right line or the right method, and you can call it. Once a test runs, there'll be a window you'll see a link to see the output of the test. You can click it, and then it'll show you what the output is. This is what helps xUnit run tests in parallel, and the output of different tests are not going to step on each other. They are captured separately by using this interface. What if you had multiple implementations for the same business logic, and you wanted users to just select different implementations for various reasons? How could you write a test that tests different implementations? And this is an example for that. You can create an abstract base class and have a function which you can override. In this example, the thing to be tested is the method, and it's a function. It's an abstract function. I have two tests here that'll test that particular system under test. And I have two different implementations for permutation. One is checking if it is a permuted string by simply sorting the characters, and the other example is by counting the number of characters and just checking if they are even. And so here you can see that the sorted class is a concrete implementation of the abstract class tester, and in which I am simply returning the method is permutation sort, which is the implementation that I wish to test. So this is a neat trick that you can use with xUnit if you have multiple implementations. You could see this when you use different repositories. Sometimes you're reading from the database, sometimes you're reading from a file, sometimes maybe you're reading from Cosmos DB. You have all these different implementations. You just want to check if they all work correctly. You could use this. Another version of this is also something like interfaces. Tester could be of type T, and then you could have concrete classes that create different types of T, and you just want to run the same tests. For example, int, short int, long int, maybe float. Maybe the test cases are similar, but you just want to make sure that all these different data types work. That's another example where you can use this abstract class and then concrete class of the specific type and make sure it meets the business requirement. I have been using Fluent assertion to assert my unit tests. Check out the website Fluent assertion. There are lots of examples. Here I'm just calling out a few samples and things that I found interesting. Using Fluent assertion, you can test for exceptions. Basically, you write a function and that function will throw. Fluent assertion puts a try block around it and checks if the expected exception was thrown. This is the example I'm reusing, where we have the first name and last name need to be checked, and if it is not provided, we expect an argument exception to be thrown with message and the given message here. It's pretty neat how you can check for two things, right? You have a throw has occurred and the message is the expected message. Fluent assertion has also got a good collection of functions to check and test collections. In this example, I have a collection with 4 different steps. I convert it to JSON and then I convert it back. Even if in this case, the order is going to be the same, but even if the order was different, when you use something like b equivalent to, it'll check just the collections are equal. The order doesn't have to be the same. There is another one that says sequentially the same if you want to make sure your sequence is also same. So this is an example of comparing two collections. This is an example I took from their website, which is again working with collections, but ability to chain multiple conditions. In this example, it's also so easy to read. It's exactly what it says. The collection should not be empty, and the number of items should be 4, have a count of 4, and contain in order, and it should be assignable. Assignable helps you check when you have objects derived from other classes. You can just check if it is of type base. So this is another good example of chaining different conditions and working with collection. Now we will look at one NSubstitute example. This is like a very simple one. NSubstitute can do lots more interesting things. Do check their site. Here is an NSubstitute example where we have an interface around the repository layer. You can inject in different implementations of iPerson, and the next slide we will look at how we could test this using NSubstitute. Notice how we call substitute for on iPerson repository to mock it. Next, we are telling it when the method getPersons is called to return the persons list with Tom and Jerry. The mock is then passed to the repository layer. Act gets the persons, asserts, checks if we got the 2 people. I hope you found this video useful. I personally made it for my own reference. I can look at some of these examples when I write code in the future. I could use it as a reference too. Thanks. Bye.